Coach Jay, it's Chapter 7 review, and it is Monday morning. Hope you have a fantastic day today. And into this week, we're going to get right straight into really our last review before our the end of the first semester. I can't believe we're already done. This is over 7.1 to 7.2 review, so as we go through, just a heads up on that. And if you got questions, come in tomorrow morning. We'll look at that together. This is an open note test for the 2017 school year. So again, if you just again take some notes down, bring those in, and we'll look at it and go from there. Without further ado, let's get started on some of these questions, and we'll go through some of the multiple choice. All of these can be found on the Chapter 7 topic page. When you go on there, just scroll to the bottom. Be sure to only do the 7.1 to 7.2. Some of the other reviews do have 7.3 in it, and I would hate for you to study that going forward. So with that being said, let's get going, and we'll rock and roll from there. Hey, what we'll do is we'll start on number 5 here. The reason why we want to start with number 5 is because I just want to numbers 1 through 4. Hopefully we'll hit on in class. If not, we can go over them maybe tomorrow morning. But this is where it starts getting a little bit tougher. And some of the concepts start meshing together, and it's a little bit harder to decipher between them. So with that being said, let's get started. On number, I believe this is number 5, states this on the review. In order to use the formula, standard deviation of x, right? And again, because that's the case, this is the population of the standard deviation, just a heads up. It equals the standard deviation, the population, over the square root of n. Okay, so we take the standard deviation normally, and all we're going to do is we're going to divide that by the square root of n. Okay, to calculate the standard deviation of the sampling distribution of the sample mean, okay, standard deviation of the sampling distribution of the sample mean, which of the following conditions must be met? Okay, standard deviation of the sampling distribution of the sample mean. Now, first off, what we want to do is to kind of identify, first off, with standard deviation, what has to be true. Well, there's 2 different formulas, and again, we hit on this in class pretty good, but there's one formula that states n is less than or equal to 1/10 of my population. Now, in order for this, or in order for us to use the standard deviation formula, the important thing to remember is this must be true. This is called our 10% condition, okay? And in order, remember, this is without replacement, all right? So when we have without replacement, what we want to do is be able to identify in our sampling distribution that n is less than or equal to 1/10 of big N. And so when we establish this, this allows us to then use the standard deviation formula. Now, this is not to be confused with this part, NP is greater than or equal to 10, or n times 1 minus p is greater than or equal to 10. This is used for normal distribution approximation, okay, of the sampling distribution. So this approximates a normal curve or a normal distribution within the sampling distribution. But this right up here is different. It looks similar, but it's actually different. It tells us that we can actually use the standard deviation formula. So that's just something to remember, something to know there. So this whole idea of which of the following conditions must be met, they're trying to trick you a little bit. They're trying to say, in order to use the standard deviation, what must be true? What conditions must be met? Well, one thing to remember is that, for instance, in number 1, we identify the fact that n is greater than or equal to 30. Well, let's just see first off if that's true. Well, big N, calculating the standard deviation of the sampling distribution of the sample mean, the whole idea is it didn't really give us much context. So the fact that n is greater than or equal to 30, we just don't know that yet, okay? Just don't know that to be true. So because of that, we're going to throw that out because it has nothing to do with this problem in terms of what number has to be plugged in or anything like that. So we're just going to say that number 1 is not true. Now let's look at 2. The population's distribution is approximately normal. Now, in order to use the standard deviation formula, the normal approximation, which is what's down here, is not a necessity to use the standard deviation formula. Now, when we use the normal distribution, we use the standard deviation, but it's not a requirement to use our standard deviation formula, which you see up here. So because of that, one thing to remember is that we don't have to use that, so the whole idea of number 2 gets thrown out as well. So now let's look at number 3. Number 3 states the sample size, which is little n, is less than 10% of the population size, what's population size? Population size is big N. So actually this right here, number 3, refers to what I just wrote down on the top right, which is our 10% condition. Therefore, number 3 is the only one that is true, or only condition that needs to be met. So we say that number 5, it has an answer of C. So we would say C, that 3 is the only one, is the only condition that needs to be met in order to use our standard deviation formula. Now, if the question had asked something along the lines of what is the, in order to approximate a normal curve in our sampling distribution, what condition would need to be met, then we would be talking about something completely different. So just decipher, really important tomorrow, decipher between this first one up here and then the second one, when it's used, why it's used, and then go from there. Let's go to number 6. Number 6 says this. Or actually, I think I skipped 6, or maybe I put it, I think I flip-flopped these. This one's number 7, okay? This one says a simple random sample of 1,000 Americans found that 62% were satisfied with the service provided by the dealer which they bought their car. Now, a simple random sample of 1,000 Canadians found that 59% were satisfied with their dealer, okay, where they bought the car. So what we want to do here is we're talking about sampling variability, or the spreading out of data. We can kind of refer to that sampling variability, or address that by going backwards and saying, okay, we remember variability is the spreading of data. So what we want to do is just try to identify what is the standard deviation for both. So let's do this. Let's put on this left side the American ones, okay? And we remember that the standard deviation formula is equal to the square root of P times 1 minus P, okay? And we divide that by our total value of N, okay? Says a simple random sample of 1,000 Canadians found that 59% were satisfied with the service. Now, this right here is actually 62% that we're looking at. 62% or 0.62 is actually our p hat, right? Okay? It's important to remember. But remember that with p hat, what we're trying to do is we're saying that 62% or that p hat is the same as what would be our true proportion, which would be, we'll say, 0.62. So let's put 0.62 in for p and identify the fact that what the standard deviation or variability would be. So we're just going to put 0.62 in. Square root of 0.62 times 1 minus 0.62 would be 0.38. Then I'm going to divide that by 1,000. Okay? Now that would be the American side. Let's do the Canadian side and let's see what we get here. So this would be the variability of the Americans. We'll do the Canadians down here right below it. Try to use a different color. But the standard deviation here would be the square root of 0.59 times 0.41 divided by 1,000. And we're going to see how the variability is adjusted or how it changes here. So again, standard deviation, variability is the spreading out of data. So standard deviation is a way, especially using the formulas we see here, it's a way that we can plug in and identify this to be true. Now, one of the things too, in order to use this standard deviation formula, we have to come back up here and say, is little n less than or equal to 1/10 of n? So really, I can't use that standard deviation formula unless I establish this to be true. This is a multiple choice question, but just in case. So if I looked at little n, which is 1,000, 1,000 has to be less than or equal to 1/10 of my population. Well, my population are all the Americans because we sampled 1,000. So N, big N, is all the Americans times 110. It is going to be much larger than this 1,000. So, and same thing with the Canadian side as well. So because this is true, I established that I can, in fact, use my standard deviation formula because, again, this is without replacement. Once I sample one American, I can't then sample him or her again, okay? So we're going to plug this in. So, again, as we go through, feel free to plug these in as well. We're going to do the American side first, 0.62 times 0.38. Divide that by 1,000. I'm going to take the square root of that answer. And I get 0.015, okay? So this right here is 0.015 is my variability there. Let's go 0.59 times 0.41. Divide that by 1,000. And we're going to take the square root of this. And I got 0.016, or really it's 5.5 if I kept going. So the question is the answers are they exactly the same? Not exactly the same, because one was like 5.4, one was like 5.5, right? So I can't be A. 2 is it not exactly the same, but very close? I'm going to come back to that when that looks good. Number 3 says much smaller for the sample of Canadians because the population of Canada is much smaller than that of the United States. Well, the population, big N, has nothing to do with, I mean, yes, it does, it's used for my 10% condition, but it has nothing to do with my, if you look over here, big N has nothing to do with my standard deviation. So just a heads up. D says smaller for the sample of Canadians because the percent satisfied was smaller than that of the Americans. Well, it has necessarily, sometimes has nothing to do with it because as we see here, we plugged it in and found that out. E says larger for the Canadians because Canadian citizens are more widely dispersed throughout the country than are, hence they have more variable views. Well, that's not even talking about variability. Variability is the spreading out of your data, not the spreading out of citizens, okay? So we're going to say the answer would be B because, again, they're not exactly the same, but they're very close. 0.0154, 0.0155 is pretty doggone close there, okay? All right, let's come back. Central limit theorem, which I believe I had skipped earlier. It's my fault there, but come back on this side. This one is number 6. Central limit theorem, stop right there. Remember, what's the CLT? CLT is N times P is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. This approximates a normal distribution, right? So if this is true and this is true, we can approximate that this distribution, which was a sampling distribution, we have all these samples, all these dots, that's approximated with a normal distribution there. So let's keep going. Refers to which of the following characteristics of the sampling distribution of the sample mean? Okay, A says this: regardless of the shape of the population's distribution, the sampling distribution of the sample mean from sufficiently large samples will be approximately distributed. That actually sounds pretty good. We'll come back to that. B says regardless of the shape of the population's distribution, okay, the standard deviation of the sampling distribution of the sample mean from sufficiently large samples will be this. Well, the formula right here has nothing to do with standard deviation. So we're going to cross off B. Though this first part is true, regardless of the shape of the population's distribution, but this whole standard deviation, that's not what we should be talking about with the central limit theorem. C says regardless of the shape of the population's distribution, again, starting off right, the mean of the sampling, well, the mean has nothing to do with it, right? Nothing to do with it in terms of the central limit theorem. So that's gone. As you take larger, this is D, as you take larger and larger samples from a normally distributed population, the standard deviation of the sampling distribution of the sample mean gets smaller and smaller. Well, if you take larger samples, if you increase the sample size, yes, this is true, but it has nothing to do with the central limit theorem. Got me? Remember, central limit theorem has everything to do with, is this distribution, can it be approximated with the normal distribution, right? Because the more dots I have, right, what happens eventually? Even if the population doesn't look normal, the sampling distribution, if taken enough dots, will approximate to a normal curve, and that's what this is looking at here. E says as you take larger and larger samples from a normally distributed population, the mean of the sampling distribution of the sample means gets closer and closer to the population. This right here on D refers to variability. And when we talk about larger and larger samples, depending on, so this is, I refer to D as we increase the sample size, we decrease variability. But as we get more samples, right, more samples, we, the mu equals, I'm sorry now, my mean equals, my mean of my samples equal mu, right? When that is true, my bias, we say our bias is low, or actually it's no bias when they're exact, but the closer they come, the lower the bias. But this has nothing still to do with central limit theorem. Let's read A again. Regardless of the shape of the population's distribution, again, that's true. It doesn't matter if the population distribution is normal or not, okay? Well, does matter. The sampling distribution of the sample mean, okay? So as I get all of these values, right, the sample mean within my sampling distribution, as we get sufficiently large samples, we can approximate using a normal distribution. So we would say A would be the correct answer, okay? All right, hopefully that makes sense there. Hopefully that we're good there. This one's a little weird just because of the way that it's addressed, but let's look at this one. In a large population, 46% of the households own a DVD recorder. Stop right there. That is referring to P, not P hat, so this is the population, will be 0.46, so we'll stop there. An SRS of 100 households, SRS of 100, so that would be N equals 100, right? And simple random sample of 100 households from this population. By the way, what's big N? That would be all households. So I want to make sure I just throw that down there. Is be contacted and the sample proportion computed, okay? The sample proportion would be P hat, okay? Which of the following expressions represents the probability that more than half of the households sampled will own a DVD recorder? Now, I'm going to take this much further than what you need to, especially when we talk about the test, especially on the multiple choice, really. On the FRQ, you'll need to do this, but just a heads up here, okay? So let's talk about this 10% condition. A little darker there. There we are. Okay. 10% condition says that that little n has to be less than or equal to 1/10 of my population, right? Well, is that true? Little n is 100, less than or equal to 1/10 of all households. We don't know the number of all the households, but I would say this is true because all households in America, that's quite a bit. So that's true. So what does this tell me? This tells me that I can actually, because of without replacement, we could actually calculate using this formula, which is the standard deviation is equal to the square root of P times 1 minus P all over N, okay? So again, right there, what we see, again, this can be found on your formula sheet, just a heads up right here. But this is true. We can use this formula. Now let's talk about the next thing, and that's this. Can I do a normal approximation? All right, that's the question. Well, we're going to go to CLT, right? Which states if both of these are true, we can. Is N times P greater than or equal to 10? And is N times 1 minus P greater than or equal to 10? Well, let's talk about the first one. The first one we see that, just right here. N is 100. 100 times 0.46 is 46, right? Is that true? Yes, it is. Okay, that first one's true. The next one, next condition that's met, by the way, both have to be met, is 100 times 1 minus 0.46. 0.46 is, or 1 minus 0.46 is 0.64 times 100 is 64. So both of these conditions are met. Therefore, we can approximate using a normal distribution. Well, you already pretty much knew that because as you see here, this idea of z-scores right here has already been established within my answers. I just wanted you to see that, in fact, the 10% condition and the normal approximation is a good way to start in terms of, especially in FRQ, which we will do. Hopefully we did that in class today and went from there. So just a heads up there. So this is using a z-score here. And so if I can use a normal approximation, we understand that in order to find what the mean is, the mean of my p hat is equal to my true mean, right? That's on the formula sheet. So since it's 0.46 over here, we're going to say 0.46 is on that side. But it also tells us what is the probability that more than half of the household sampled on a DVD recorder. Well, if it's more than half, we're just going to make this 0.5 over here, okay? We're going to make this 0.5. We're going to highlight what's to the right of that, okay? So really what we're doing is we're saying, okay, what is this whole P of is just means the probability of, so we know that that's consistent throughout. But we know that the Z score is equal to X minus X bar over the standard deviation. Well, we can actually change this up a little bit because this right here, this X bar is just the mean of my normal distribution, which would really be my, we could just say my P, right? Or the mean of my P hat, let's say, we'll call that P. So we could just say the value of X, right? Or you could even say that's P hat, but we'll just say X or P hat, you could say either one here, is subtracted by my P, okay? Divided by, and then my standard deviation formula, which is right here, can be put there. So then how do I find my standard deviation of this? I do my P times 1 minus P all over N, right? Now let's plug in and see X is 0.5 minus P, which is 0.46, right? Divided by the square root of P is 0.46, right? Times 0.54 divided by the n, little n, which is 100. And since this is z over here, really we're saying that z has to be greater than, right? We're talking about whatever's greater than that 0.5. So when we solve this, or when we find this, we come to it and we say, okay, which one was true? And so as I look at this, I notice that I think the one that matches up would be, that'd be E, is that right? Trying to make sure I got this one right. Yeah, so this right here on this would be E, because as I look at it, Z has to be greater than, because look up here as we do this here. Now, this is a lot more, you don't have to do everything to this right side over here. Once I notice that, in fact, that we can assume that the 10% condition exists, you can kind of just eyeball it. You don't even necessarily need to write that on multiple choice. And then I could go and just do whatever's on this left-hand side here, okay? Excellent. All right, now let's go to my next few here, number 4, and this right here is where I really want to kind of chill, hang out here, okay? All right, so let's do number 4, and then there's a couple others that we can hit on here, and maybe I'll do in class as well. According to a poll, 22% of high school students in the UK say that Dobby is their favorite character, okay? So let's talk about this first. First off, we recognize that P is equal to 0.22 because it's the population. And remember, context, it's all UK students. All right, say that Dobby is their favorite character in the Harry Potter book. All right, let's assume this is the parameter value of the population high school students. You take a sample of 150 high school students. So before we do any of this, all right, we know that big N is UK students, all, okay? And we know that little n is, thanks, Phil. Appreciate you. We know that little n is 150 high school students, right? and the proportion of p hat, so big P of here would be 0.22, and the p hat of individuals is where we're at. Okay, so the question is what are the mean and standard deviation of the sampling distribution of p hat? So first off, before we do any of this, what I would do is let's talk about, I would establish first off, and then I can always point to different things, but I would establish the 10% condition, okay? Which tells me that I can use my standard deviation formula, right? Without replacement. Deviation formula, okay? All right, so let's talk about this. First off, we know that little n, if that is less than or equal to 1/10 of my population, okay? My big N is UK students, which is like a ton, right? You could actually, you don't even have to show this. Is that less than or equal to 150? Yeah, I would say so, because UK students, that's a lot. And so we could say 10% condition is met here, okay? All right, so let's go to the next thing, which is my central limit theorem. What is this important? Why is this important? This is important because it estimates a normal distribution from sampling distribution, okay? So we're going to see, is this true? So what we do is we're going to show is n times p, is that greater than or equal to 10? Well, we can do this, right, by first identifying what p is, and do n times 1 minus p, is that greater than or equal to 10? Well, p is 0.22, right? So we could say 150 times 0.22 is greater than or equal to 10. Really show that out, okay? So as I look at that, I'm looking on here because I'd already done that here. It was like 33. So 33 is greater than or equal to 10. I would actually write that down below. So 33 is greater than or equal to 10. So that condition's met. Over here, n is 150 times 1 minus p, or this would be like 0.78. Is that greater than or equal to 10? So 150 times 0.78 would be 117. 117 is greater than or equal to 10, right? So that condition's met. So based upon this, and we don't necessarily have to put context with this yet, but I would start with this. If I look at standard deviation and mean, talking about that, right? And looking at the questions, and we have to find, like, what are we trying to find? This is going to be a huge help to us, because then we can always point back. So when it says what are the mean and standard deviations, first off, we can say the mean of p hat is equal to the true proportion p. And the standard deviation is equal to the square root of p times 1 minus p all over little n. What I can say, though, is because I've already done the 10% condition, I can say something about the fact that the standard deviation can be used due to the 10% condition being met, okay? All right, so this right here we can actually find. Now, when I plug in the standard deviation, and I'm guessing you know how to plug stuff in there, okay? Maybe that's on me, but this would be the standard deviation of p hat here, and this would be equal to 0.034, okay? Boom. And with that context, right? I've already found the 10% condition. I've already established that. The mean of p hat would be equal to the p, so the mean of p hat would be equal to 0.22. We've got that there. We don't have to establish anything for my mean. Now, part B says, what is the approximate shape of the sampling distribution? Well, where shape talks about, is it skewed? Is it normally distributed? Is it symmetrical? So we would say, literally, we've already proved the CLT down below. And I would actually put this up here, okay? That central limit stuff, or at least draw an arrow, and say something to the effect of, since the central limit theorem was met, we can say the sampling distribution, I might put context here because I want to establish context. So distribution of high school students of 100, because it's a sample, or 150, I'm sorry. 150 high school students whose favorite character is Dobby. We can say the sampling distribution of 150 high school students or whose favorite character is Dobby will be approximately can be, I know it's way out here, normally approximated, okay? I know that's way out there, but hopefully you see how that's written to even go back and kind of rewrite it yourself in your own flair, okay? The next one says, suppose our sample was 36 instead of 150. Compare the shape, center, and spread. Okay, so first off, let's talk about a couple things here. We know that so this is new, right? So let's talk about this. Let's talk about mean, which is the center. The mean of p hat with this is equal to p, right? Because the n is 36 here on the new one, that has nothing to do with my mean of my proportion, right? Or mean of my sampling distribution. So what I can say here is that 36 does not have any impact on the center. So the center is unchanging, okay? All right. Let's talk about my standard deviation, okay? The 10% condition still would be met. And you don't have to say that really again, I don't think, unless it asks for that. But you could just say that this would be equal to, let's say that it has the same thing. So let's say that it's still p times 1 minus p and divided by n. Well, this time, instead of having 150, we have a smaller value, right? And so because it has a smaller value, we could say that the standard deviation won't be, like if I divide by a smaller value, that means the standard deviation will be larger, right? So we would say that the standard deviation of our sampling distribution would be equal to, and when I plug this in, where n would be 36, we find that it would be 0.069, which is larger than n equals 150, okay? And so we have shape, we have center. Now let's talk about, we have center, we have spread. Let's talk about shape. Shape can be found by doing the central limit theorem. Can we still prove that? So this time we're going to do 36 times 0.22. 36 times 0.22. Is that, well, let's think now. 36 times 0.22. I'm actually using my phone on this one. Okay, that'd be 7.92. Is that greater than or equal to 10? No, it is not. So because of this, this cannot be normally approximated. So that would make the shape definitely different, okay? So shape changes, and something to the effect of the central limit cannot be used for this, so we cannot assume that it will be normally approximated, okay? It's actually we call it non-normal. Now with the part D, I've got to get going because I've got literally a minute here. When we talk about, let's say the population was 600, what is the largest possible sample you could take from this town and still be able to calculate standard deviation? We remember standard deviation, which is the 10% rule. N is less than or equal to 1/10 of my population. If my population size was 600, we would say that based on the 10% condition, this would be 60 on this side. The sample would have to at least be 60, or the highest it could be was 60 or anything less than 60 for this to be true. Because in order to do that, the 10% condition would have to be in effect, okay? The book says the largest sample we can take is 60, otherwise the sample would be more than 10% of the population. Sampling without replacement will require a finite population correction point to calculate standard deviation. Just a heads up there. Hey, I hope this was helpful for y'all. Good night. I know that y'all are all in it, and I appreciate your enthusiasm and effort. Hopefully we'll go over this today and establish this today as well. We'll see y'all.